All right, now that we've went through and talked about kind of the difference between the radians and degrees, we're going to talk about how to find arc length. Now, again, up at the top, I've written what you saw on the front page of the notes. The arc length is just a fraction of the circumference. So if I want to find a fourth of the circumference, right, I would just take 1/4 and I would multiply it by whatever the circumference is. If I want to find half of the circumference, I find the circumference, multiply it by a half, or in other words, divide by 2. So essentially we're just finding pieces of the circumference, okay? And remember, and I've written off again to the right, that the circumference is equal to either 2 pi r, right, or pi d. So we're going to kind of look at that. So essentially when we say determining the length, and I'm going to draw this on the left here, basically we're just saying, okay, well, we have some section of our circle and we're given a central angle. So the angle on the inside, which may be, maybe in this case, this is like 50 degrees. That right there is the central angle, right? And we use that because it tells us how much of the circumference we're finding. Okay, then this piece on the outside, that little section, that arc that we've been practicing identifying, this is what we're trying to find, right? Now the arc length is the actual measure of that arc. If we wanted to know the degree measure of the arc, we know that that would be the same as the central angle, which is 50 degrees. Okay, so understand there's a difference there. We could say that this is also 50 degrees, but if we know the length of the radius, then we can actually find what that arc length would be, not just the measure. Okay, so today we're focusing on length. So if it's in degrees, again, you're just finding a fraction of the circumference. So I'm going to write out a formula, but really what I want you to realize is it's just 2 pi r. Okay, and again, this represents the circumference. Okay, and then you just need to times that by your angle over 360. That gives you the fraction, and this angle's in degrees, right? So that gives you the fraction. So you're taking the circumference, multiplying it by a fraction so that you can find just a piece of the circumference, okay? Now, if the angle measure is given to you in radians, and remember we know it's in radians if we see that there's not a degree symbol, then because radians it comes directly or relates directly to the radius, we just take whatever that angle is and we say, well, it would be that many radiuses to get us there. So let's practice with that just a little bit. Determine the length of A to B. So we have arc A to B there. We're looking at this guy right here. Now again, it's asking for length. If it was asking for measure, we would know that the measure is 45 degrees, right? Because that's the central angle there. But length. So we just want to find a piece of the circumference, okay? So what we're going to do is we're going to say, okay, well, the arc length, right, of AB is equal to, and we're going to use this guy right here because we're in degrees, okay? So we're just going to say, well, the circumference would be 2 pi r, and my radius here is 12. So I'm going to put 12 in here. And then we're going to multiply that by the central angle divided by 360. So in this case, we've got 45 degrees over 360. I'm going to put that in parentheses just so when you're plugging it in your calculator, it kind of makes sense what you're looking at there. So again, we're just taking the circumference, what we practiced on our last assignment, and then we're multiplying it by the fraction of the arc that we want to find. So once you calculate that, again, this one didn't ask for exact, so we can just approximate that, and you should end up with about 9.4. And it didn't give us any units of measure, so we're just going to say 9.4. Okay, again, let's walk through that process one more time. Notice that this guy over here, we're finding the length of PQ. So we're finding the length of arc PQ. Oh, that's a Q. So we just say, okay, well, the circumference would be 2 pi r. My radius in this one, it looks like, is 9. And then we're going to say multiplied by the central angle, which is 60 degrees out of 360. So when we multiply this, we plug that into our calculator, and actually we end up with 9.4. Now you might be asking, how are those arcs the same length? I'm sure that's what you're asking. The reason being is, right, the radius is smaller on this example right here, but notice that the angle measures a little bit bigger. So we're finding a bigger portion of that circumference, even though in total that circumference of this guy would be smaller. So again, that radius relates directly to the length in proportion to the angle that you're finding. So let's look at these next two. The next two are in, or I'm going to jump to 14. I'll come back to 13. This says determine the value of arc S. So we're shown there, arc S is there. Notice if you look at the central angle, this is pi thirds. That's no longer in degrees. This guy is in radians. So we are going to say, okay, well, let's look up here. A radians relates directly to the radius length. So we're just going to say, all right, well, our arc length here, or I'm going to say S, is equal to pi thirds, which is that angle in the middle, times the radius, which in this case is 3. So if you multiply, right, that there, that's the same thing as that guy. So those 3's go away, and actually S is just equal to pi. So in this case, the length of that would be about 3.14. Okay. Again, this one's radians, so you've got to be able to recognize kind of the difference there. All right, a couple more examples. So number 13, determine the value of the central angle. So this time we don't know the angle in degrees and radians. Okay, so we could use both of those relationships to help us find first in degrees and then in radians. Notice if we're talking about radians, I know this is weird, but I'm going to do B first. Radians is just the length of this radius and how many times would it wrap around. So notice if that is radius length is 3, and I were to start wrapping my radiuses around here, that would be 1 to get me halfway, and it would be 2 to get me that full way. So I actually already know that that one is going to be 2 radians. Radians are really, really nice that way. Okay. If I was using the formula like we did on 14, we could say that the arc length, or in other words 6, would be equal to the angle times the radius. Right, and notice when I do that, I'm going to divide by 3 to solve for theta, and we get 2 radians. So either way, you can conceptually kind of work through that one or calculate it algebraically. All right, let's jump up to degrees. Again, we're just going to use our degree formula. So if you need to be reminded of what that is, you can look back up at your degree formula there. And we're just going to plug that in here. So again, we know the arc length is 6. That's going to be equal to, right, 2 pi r, and our r in this case is 3, times theta over 360, right? And we're solving for theta. So you can solve that in different ways. If you want to get rid of the 360 on the bottom, maybe you could just go ahead and multiply both sides by 360. That would get rid of that fraction, since we love fractions. And in this case, that would give me 2160. If I multiply the 2 and the 3, that's like 6. And then you still have your pi there. And then that's like times that theta. So if I'm solving that, this is very similar to when we dealt with our circumference equations. We just divide the 6 pi so that we can solve for theta. And remembering when we're plugging it in the calculator that we want to put parentheses around that. So in our calculator, we put that in, and theta ends up being approximately 114.6 degrees. Now, if I knew that that was 2 radians, I could go ahead and do that conversion as well and end up with my degree measure. So we should be able to kind of look at that piece. Okay, so that's kind of going backwards with those formulas. So you're going to practice those. 15, very similar. Determine the circumference of circle N. Notice it already gave us the arc measure. So this guy sitting out here, that is the arc length. And you're given your central angle is 270 degrees, and it wants us to find the circumference. So remember, when we find the arc length, we really want to find, so here's arc length is equal to, and we took the circumference. Now we wrote it out as 2 pi r in our equation, but really it was just whatever the circumference is times, right, this over 360. That's what we were looking at there. So when we plug these values in, let's go ahead and put the arc length in there, 61.26. That's equal to the circumference times theta, which is our central angle there, 270 degrees over 360. Okay. Now you can simplify that fraction. If some of you like decimals better, since we have a decimal on the left, that's the same thing as multiplying by 0.75, I believe. And then we're solving for the circumference, so we divide by 0.75. Okay, and that tells us that the circumference would be about 81.68 meters. Okay, and then we just look back to make sure that that makes sense. So if this is 61.26, it would make sense that the circumference, right, is bigger than that. And if that's about 3/4 of the circle, then this would make sense for that to be our circumference. Okay, just make sure that it makes sense there. All right, a couple applications, just so you have a few examples of these. So number 16 says a car tire has a diameter of 28 inches. How many revolutions? So this is asking how many revolutions. Now when you talk about circumference and you have something that's going around and around and around, think about your circle. Let's see if it'll help me draw a good circle. Yes. If I were to cut this circle right here and I were to lay it out in a flat line, right? Then basically one circumference is the same as once around the circle. So if this is a tire, because that looks like a tire, okay, let's not do that. Okay, here's your car tire. If it's going to roll along the road as you drive, by the time it goes from here all the way around once, that's like one circumference, right? Once around would be one circumference in distance. That's also what we call one revolution. Okay, so one circumference is one revolution. So we want to know how many revolutions does the tire make while traveling 500 feet. So if we take 500 feet and we figure out how many, so we're going to divide it by the circumference, right? If we can divide it by the circumferences, that'll tell us how many times it went around. So let's find the circumference of this. It says that it has a diameter of 28 inches. So remember, circumference is equal to the diameter times pi. So 28 pi. But notice that's in inches. And you want to know with 500 feet. So you can either convert one way or the other. Remember to convert 28 into, to convert inches to feet, we are just going to divide by 12. So 28 divided by 12, well, that's the same thing as 3/7 feet. Okay, so our circumference in feet is going to be 3/7 pi feet. So we're going to come up here and we're going to say, all right, well, we're going to take 500 feet, divide it by 3/7 pi feet, and that will give us the number of revolutions. So if you divide that, we get 68.2, right? So we know that the tire is going to make 68 revolutions. Okay, so one revolution, again, is one circumference. Number 17, a motorcycle tire has a diameter, again, diameter of 24 inches. Approximately how many inches, so now we're looking at distance, does the motorcycle travel when its front tire makes 3/4 of a revolution? So just again, this is worded differently, but I just want you to recognize it's the same thing you've been practicing here this whole time. All we're saying is here's a diameter of 24 inches, and your tire is going to move, but not very far. It's only going to move around your circle 3/4 of the way. Okay, so essentially, again, you're just going to say, okay, well, I'm going to, in order to find the distance there, I'm going to take my circumference, but I only want 3/4 of the circumference. Okay, so remember, circumference is pi times diameter. So our diameter there is 24 inches. There's my circumference, and I'm going to times that by 3/4. Okay, and then I can calculate that and come up with how many inches that would be. Okay, again, practicing just finding that arc length. It's just a fraction